Hello, my name is Javier, and the experiment I'm presenting is called Soda Straw Rocket. In this experiment, students will construct small indoor paper rockets to determine the flight stability and launch them by using a rocket launcher. All the materials that you need will be a sheet of paper, tape, scissors, ruler, meter stick or tape measure, eye protection, drinking straws, or a copy of SLS paper rocket plans. Cut a strip of paper for the rocket body, use a straw as a form and roll the strip around the straw. Then tape the long seam. Then close off one end to make a nose cone. Later, then you cut out 3 or 4 fins and then tape the fins to the lower end of the rocket. Bend them outward to space them equally. And this is what the students did. To check if the rockets were stable, they hold the rockets horizontally at eye level and drop it to the floor. If the nose of the rocket hits the floor first, the rocket is stable and ready for flight. If the rocket falls horizontally or the fin end hits first, the rocket is unstable. Insert your rocket into the rocket launcher. Watch as your rocket flies. The questions that they asked in the paper were: how far does it go? Does it fly straight or does it tumble in midair? Then later record the rocket's length and how far it travels using the template's data log. Launch your rocket a few more times to see if it flies the same way. If you would like to record your rocket's flight distances, be sure to launch it from the same place each time and measure the landing spot with a tape measure. Next, the students will use the SLS Layout to see the difference between their rockets and to see if it's better or theirs is better. They will record the data and compare the averages and see which one had the better distance and stability. The students recorded their data on the paper given to them. They noticed that each of the trials had different distances. So they averaged each out and they figured out how much each of them give them. They noticed the SL was lower than the one they did. The reason was because there was less weight on it and it flew less because of the air resistance, causing them to believe that their own blueprint was better than the SL. Way to find which blueprint is better for a more stable rocket, and maybe helping scientists to find a more effective rocket for space expeditions. This experiment is just a way to be more fun and be more creative with your rockets and have fun with your friends.